Hello and welcome to the lecture on multiplication and division. So if you are starting on this lecture, I would advise that you go back to the addition subtraction lecture because a lot of the terminology and some of the stuff that I'm going to use in this lecture would have been explained in that one. Also, just as a reminder, one of the extra resources that you can find for this are in the section of the course where the textbooks are held in the Learning Resources section under the Algebra 1 unit file. And then the two booklets we'll be using today, or like not the exact booklets, but the content in it will be the multiplication and the division booklet. But we're going to fit it into one lecture because they do sort of go smoothly together, and we'll try to get it all done today. Okay, so we're going to start with multiplication. This seems to be the easiest place to start. And in multiplication, when we have expressions that are equal to one another, we have this commutative law of multiplication. And basically all this means is that it doesn't matter what the order is of the variables when we multiply. It means the same thing. So typically, and you'll see this in the next slide, we try, not the next slide, but a couple slides from now, we try to keep things in alphabetical order, sort of like in communications or English where you have grammar and proper grammar and proper rhetoric, similar to math. So we try to keep them in alphabetical order. That does not mean, though, that if it's not in alphabetical order, you would get the question wrong. It's just sort of a habit that we like to try to get used to as we go forward. So it's just saying that A times B is the same as B times A. And ABC, we could say CAB, BAC. Everything's being multiplied together. So because of that, it does not matter the order, but again, we just try to keep it in multiplication order. Sorry, I had to cough. I meant alphabetical order. So a couple things. You don't really need to memorize this. Your calculator will do this for you as long as you're inputting the signs properly. But when we have two signs that are the same, so two plus signs and two negative signs together, being multiplied together, this will give us an overall positive answer. So two of the same signs results in a positive. When we have a positive and a negative, or a negative and a positive, or in other words, two opposite signs, this will result in an overall negative answer. So again, not something you need to memorize. Your calculator will do all of that for you as long as you're inputting the signs properly. So we're just going to start with some numerical problems. So just your typical numbers together. So we like to start here before we get into the letter. So 7 times 3, if you don't have this memorized, that's fine. You could type this into your calculator. But when we have the 3 and the 7 and there's no plus sign in front, right? So there's no sign in front, it's understood that the sign is positive. And this is really important to keep in mind through all of algebra. As I always say, mathematicians are lazy. If we don't have to write something, we won't. So if there's no sign in front, it's understood to be a positive number. If it's a negative, the negative sign will be there. So in question 2, we have a negative 4 times 5. So when you're typing this into your calculator, you're going to just want to make sure you use that plus minus button on the 4. So not the subtraction button, but the plus minus button. 4 times 5. But as per our rule that we talked about in the slide before, a negative times a positive is going to result in an overall negative sign, and then 4 times 5 gives me 20. So in question 3, I have two of the same signs, both are negative. So I have a negative 3 times negative 5. So because they're the same sign, my overall answer will be a positive. But we know that we don't have to write the positive sign, though if we do, it's not wrong. So we get a positive 15, but we could have just written it as a 15. So again, writing the positive sign does not make it wrong. It's just how we tend to write it in math, is we don't write the sign unless it's a negative. So then 7 times negative 2, we have a positive on that 7. We don't see it, but it's there, times a negative. So my overall sign will be a negative, and 7 times 2 gives me 14. Sorry if I'm taking lots of pauses in the audio. It's because I don't want to cough into your ear. I still have that cough that I had in the first video that you watched. So I apologize, but unfortunately it has not gone away. So when we use algebra, we usually leave out, well, we actually always leave out the multiplication sign. And the reason for that is because the variable that we love to use in algebra is that x. And that x can get confused with that multiplication sign. So we tend to use brackets most of the time if we need to separate two things and tell whoever it is that's doing the question. Now, this probably wouldn't be written this way, but basically everything's being multiplied by each other. Those brackets without a plus sign in between or a minus sign, like a subtraction or addition, indicate when they're touching like this that it's multiplication. So 3 times A would just get written as 3A. B times C would be written as BC. And then 1/2 XY could be written as like just 1/2 XY, or it can be written as XY over 2. Both are right. So, oh, there you go. See, I went and thought that was an X, but that's not the point of this question. So that's why we don't use X's, sorry, multiplication signs, because it looks like an X. So just 1/2 times Y would look like 1/2 Y or Y over 2. So perfect example of why we don't use multiplication signs. So here we have 2A times 4B. So we have in the first part, in this part, we used a multiplication sign, but again, we're going to stop using those and we're going to get used to using brackets. So 2A times 4B, the 2 times 4, we'll talk about this more in the next couple slides, but we multiply the coefficients first. So the 2 times 4 gets multiplied by first. So 2 times 4 gives me 8, and then A times B gives me AB. So again, just leaving it in alphabetical order. So we multiply the coefficients first, and then we put the letters together. Okay, so here, the rule off to the side, and it's what I just talked about in the previous slide, but here's the little bubble rule. Sorry, 1 minute. Okay, it's gonna be a hard one to get through. Cough is much worse today. Okay, so when we multiply these two together, we multiply the numbers first and then the letters. So we always write the letters in alphabetical order. Again, if you don't, it will not be marked incorrectly. So if you write the Z before the Y in part I, that's fine. So we have a 6Z. We have multiplication written in these examples, but again, in most of the questions, actually in all the questions you have, I think, in your assignment, the multiplication sign will be replaced with a bracket. So it would usually look like 6Z bracket 6Y. So in any case, what we do first is we multiply the coefficients or the numbers in front first. So 6 times 6 is going to give me 36. We have Z times Y. If I want alphabetical order, the Y comes before the Z. But if you gave me 36 ZY, that would have been fine too. Okay, so for J, we have a 4ZY times a 3M. So we're going to multiply the coefficient first. 4 times 3 gives me 12. Now we have a Z, a Y, and an M. So M comes first, then Y, then Z. Again, I'm not really picky, and most people aren't picky, like most teachers aren't picky when it comes to this. For K, we have 3CD times 4T. So 3 times 4 gives me a 12 again. And then we have a C, a D, and a T. So we can just write those side by side like that in alphabetical order. Okay, so for L, we have 6AB times 4N. So 6 times 4 gives me 24. We have an A, a B, and an M. So alphabetical order is pretty much done for us. Let's just pop down to question P, example P. So we have 2MN times 5ABC. So we're going to multiply the 5 times the 2. So that'll give me 10. and then we have an A, a B, a C, an M, and an N. So we're just writing them all side by side. We can remove the brackets, remove the multiplication signs, multiply those numbers as though they were just there on their own, and then combine the letters in alphabetical order. Okay, when we multiply literal coefficients that have the same base, we can add the exponent. So here, we talked a bit about this in the addition and subtraction booklet, or sorry, video, but the P, so if this was addition subtraction, the rules would be different, right? We'd have a plus sign or a minus sign in between here, and we would look for variables with the exact same variable, so the exact same letter and the same exponent. In this case, we're only looking at the letter. So I have a P squared and a P. So this P squared and this P can get combined, and what we do is we add the exponents. So that's, maybe let's look at just a more basic example. These ones are maybe a little bit too hard to start. So let me just go back to the whiteboard here. Because I think we jumped into that one maybe a little bit too quickly. So if I have a P squared and I have a P next to it, so these two are being multiplied, right? So these brackets again indicate multiplication. We know, and we talked about this in the last video as well, this P has a 1 up there. An exponent of 1. Mathematicians are lazy, we don't write them, but we have to remember, and sometimes students even like to write the ones in everywhere so that we don't forget about them. But we have to, this is really important, especially with multiplication, because we have to remember to add that exponent. So, sorry. So for this question, we have a P, and we're just going to add the 2 plus 1. You don't have to show this step. This is just more so here to for the first couple examples, but what we're doing is we're adding the exponents. So 2 plus 1. 2 plus 1 is going to give me a 3. So my overall answer is P to the power of 3, and this would be my final answer. So we have this rule. If I have A to the power of B times A to the power of, so we have this rule. If I have A to the power of B times A to the power of C, so these are just rules, then I add the exponents. And we'll talk about the different rule when we have an exponent raised to an exponent later. But when I have two variables side by side like this with different exponents, but the variable is the same, I can add them. So let's say I had an x squared times an x4. Then I would get x2 plus 4. Again, you don't have to write that part, but we're just going to do that for the beginning. So I would get x to the power of 6. So let's go back to the PowerPoint. Okay, let's pick up where we left off. So now that we talked about that, we can do this with more than one variable. So in the last one, we just had the same letter being multiplied, right? But here we actually have a few. So we have P squared, so we have P's and Q's, right? So the P squared and the P1 can get combined. So my base is gonna, or my variable is gonna be P. I have a 2 plus a 1, right? And then I also have a Q. Now notice how I'm not doing an addition sign in between here, because remember everything's being multiplied together. So just like in the previous slide where we had an A times a B times a C like that, and we just rewrote it as ABC, it's the same thing here, except we're also going to have to account for those exponents. So I have a Q to the 1 here. So again, there's a 1 there, let's not forget about it, and then a 4 on the other one. So I'm going to end up with a P cubed and a Q to the power of 5. So all I did was take my letters that are the same, add the exponents. So in the first few examples, you'll notice I did multiplication signs, but eventually we're going to switch into brackets like we do in the next couple. But let's look at the second one. So we have r squared s cubed times r4 s7. So my r, I have a 2 plus a 4, and my s, I have a 3 plus a 7. So I get r to the power of 6 and s. Did I write that out right? Yeah, okay. S to this power of 10. I hope it's bigger for you on the recording than it is for me because the letters are really small. But anyway, again, you don't need to write this step. It's just here. So in the next ones, I'm actually going to skip that step. And we're just going to look at the exponents. So in the next one, I'm going to write the ones where I don't have them just to get in the practice of doing that. You don't need to do that. But students often wonder where the heck I got the extra 1 from. So we're just going to make sure we account for that. So for my p's, I have a 1 and a 2, and everything's being multiplied, right? So I'm going to go 1 plus 2, so I have 3 p's, or p cubed. And then my q, I have 4, and then I have 3, so I actually have 7 total q's. So we're adding these all up. A way to think about it, and I didn't really talk about that, but let's say I had p squared times p cubed, right? So this is saying I have this many p's and this many p's. So how many do I have total? 1, 2, 3, 4, 5. So I have 5 p's. This is the other thing we're doing, but instead of writing it all out like this the long way, which would take us forever when we get into these bigger questions, we're getting in the habit of just knowing to add those exponents together. So it's kind of why we can do it and where the law comes from, but it's easier to just know to add the exponents. So now we have x's and y's. So I have a 1 here, and I have a 1 here. The rest are all accounted for. So for my x's, I have 1. So even if there's more than, like it pops up 3 times, right? But I have a 1 plus 2 is 3 plus 2 is 5. So I have 5 x's. And then for my y's, I have 2, 3, 4, 5, 6 y's, right? So all I did was add all of my numbers together as though I was adding them together. So maybe I'll write that one out. We had 1 plus 2 plus 2. And then I had 2 plus 1 plus 3. So that's where this came from. Oops. Okay, hopefully you're with me so far. Again, it's really weird not to have students to sort of ask questions and give feedback, but just a reminder, if you do have any questions, you can see me during office hours, or if you're not part of this class, you can ask your instructor that you're working with. Okay, so for these questions, we have the same thing happening here, but we're just going to do some more practice. So now we have numbers that have a sign in front of them. So that's kind of why we started with the sign numbers first, and now we're going to tie everything together. So what we want to do, if you're not going to use a calculator and plug it into your calculator, then you have to know these rules. So we want to count how many minus signs we have. So if I have an even amount of minus signs, so 2, 4, 6, 8, 10, then my overall result will be positive. If I have an odd number, so these are the rules I'm talking about here, of negatives, then my overall sign will be a negative sign. So what we're just going to do is we're going to count how many minus signs we have, then we're going to multiply our numbers, and then for every letter that has the same base, we're going to add the exponent. So we're tying all of these rules together. So, sorry, I didn't have a chance to turn the mic off there. For the first 2 numbers, we have 2 times 3, so we don't have any sign numbers to worry about, so we just have a 6. That's great. Then I have an x to the power of 2 and an x to the power of 3. So again, we're just adding those exponents. 2 plus 3 gives me 5. So 6x to the power of 5. In question 2, I do have negative signs, and I have an even amount. I have 2 negative signs. So my overall sign will be a positive, which I could write, but I'm not going to. So overall sign of positive, and then 4 times 2 would give me that 8. And then I have x. 7 plus 3 would give me a 10, so 8x to the power of 10, and that's my final answer. So again, we're just multiplying our coefficients and making sure we keep track of those signs. So now I have 1 negative sign, so that's an odd amount. That gives me a negative. My x's, don't forget about this one here. So I have 5 x's, Oh, sorry. I forgot to multiply the coefficients. I'm going to erase that. Got ahead of myself there. Okay, sorry. Negative 3 times 5 is 15. Now I can do my x's. So I dealt with my numbers. So I have 4 plus 1 gives me 5. And then my y, I also have a 1 here. So I get 2 plus 1 gives me 3. So negative 15, x to the power of 5, y to the power of 3. For number 4, I have 3 negatives. That's an odd number. So my overall sign is negative. 2 times 3 is 6, times 2 is 12. So I get a negative 12. Now, if you wanted to use your calculator, negative 2 times negative 3 times negative 2, let's take a quick look at that and how you would punch that in. If you don't want to memorize these, or if you're in a test situation or whatever and you can't remember, you can always pop back to the calculator. Just give it a minute to switch over here. Okay, so I have a negative 2 times negative, a minute to switch over here. Okay, so I have a negative 2 times negative 3 times negative 2. So again, we're using this button as a negative, not subtracting, a negative. That gives me an overall negative 12. So same answer, right? So this is the button you want to use, not the subtraction button. Subtraction is for subtraction, and that is to input a negative instead. So go back to where we were. Where were we? There. All right, so we got that negative 12. Now we've dealt with our coefficients. Now we can do our x's and our y's. So we have x, I have 2. I have none in the second one, so I don't have 1 to add, I have 0 to add, but there is 1 here. So I have 2, I have 3 x's. And then for y's, I have 4, 5, 6, 7, y to the power of 7. So that's my final answer because I've used up my x's and my y's. So for number 5, this is our last one until we move on to the next rule. So on the first like bracketed expression here, we have p squared times q. So the question is, does that mean I have a 0 in front of the p squared? No, there's again a 1 there. So there's a coefficient up here of just 1, right? So 1 is still a positive, so that counts as just it's not a negative sign. So I have 1, 2, 3 negative signs. Okay, sorry. I have 3 negative signs. So an overall sign of a negative. I have a 1 here, a negative 2 here, a negative 4 here, and a negative 1 there. So again, you don't see the 1 in front, but there is a negative 1. So 1 times 2 is 2, times 4 is 8, times 1 is still an 8. So we get negative 8. If that is way too much to do in your head, again, let's throw out that calculator. So you're going to go 1 times negative 2 times negative 4 times negative 1, and that'll give you an overall negative 8. And now it looks like I have a few letters. I have a P, a Q, and an R. So let's just write the letters, and let's figure out how many we have. So for P's, I have 2 plus 3, so 5, 7. 7 P's total. I have 2 in the first bracket, 3 in the second, and then I have 2 in the last one. So 3, 4, 5, 6, 7. My Q, I have 1 there. So I have actually, I have 1 here too. So I have 1, 2, 3, 4, 5. So I have 1 plus 1 plus 3, so 5 Q's. And then for my R, well, I only have the 1. So I actually don't have any R's I can combine it with. So I'm going to just, you could put a 1 up here, or you could just, be a mathematician and be lazy. There's probably a much better word for it, but that's just what I was told my whole life. And erase that negative, or that 1. So your final answer would be negative 8, p to the power of 7, q to the power of 5 times r. Okay, so we have another rule when it comes to multiplication. So in those rules, we had a letter, like a variable times another variable with the same base. in this case, we have a variable raised to a power raised to another power. So we have kind of like double exponents happening here. And when this happens, we end up with this rule. So if I have a letter with an exponent raised to another exponent, I have to multiply those exponents together. So in the last ones, we were adding them together. When this happens, I multiply them together. And if there's a numerical coefficient in front of the bracket, it also has to be raised to the exponent. So that means that like if I had a 2x squared to the power of 3, this 2 inside the bracket also gets cubed. So it's basically saying 2 cubed times x squared to the power of 3, right? So the 2 is getting cubed and the x squared is getting cubed. So the 2 cubed, how do you do that in your calculator? Well, let's bounce back here. It's going to be kind of annoying to shuffle back and forth, but I feel like it'll be worth it. Oh, my calculator's not showing up. Okay, so to get 2 to the power of 3, that's going back to this exponent button, so we can use this one. This one's also a shortcut, so this will just cube it, but what if we didn't have a cube? We could use this one for any exponent. So 2 to the power of 3 is going to give me an 8. So the biggest mistake students do here, instead of actually doing 2 to the power of 3, they do 2 times 3 and get an answer of 6. But remember, it's an exponent, so we have to enter it differently. So 2 to the power of 3 means 2 times 2 times 2, which is why it's an 8. Okay. I know that was a lot of work just to explain one thing, but unfortunately there's no shortcut. Okay, so 2 to the power of 3 gave us an 8. And then, like we said, we multiply those exponents. So we're not going 2 plus 3 and getting a 5, we're going 2 times 3. So that gives me a power of 6. So 8x to the power of 6. So that's what that rule means. Like, just to remind you, if I had x squared times x cubed, I would add, because I have exponents as my base being multiplied together. So it's not raised to another power. So I would have had x5. But if I have x squared to the power of 3, then I have to multiply, and that gives me an x6. So that's the difference between these two rules. And it's a big one to keep in mind moving forward, because it's one of probably the bigger mistakes students make on assignments and stuff. So -1 to the power of 5. So you can punch this into your calculator, but let's just think about it. So I have 5 of these guys, right? So 3, 4, 5. So I know I have an odd number. So I know that means I should have an overall negative. And 1 times 1 times 1. So 1 times 1 as a million times still becomes a 1. So -1 to the power of 5 gives me a -1. If it was -1 to the power of 4, it would give me a +1 because it has an even amount. Okay. So we did the second one already on the previous slide. So we did this one together, so we'll skip that one. But let's do this one. So we have -2 x squared to the power of 4. So I'm going to split this up. You don't need to do this, but just for the sake of learning, I'm going to split this up. So -2 to the power of 4, you're going to go in your calculator and punch this in, or you can do -2 times -2, which I mean you might still need to use a calculator for anyways. But basically -2 to the power of 4, it's going to be an even amount of negatives, right? So it should be a positive overall. And then 2 to the power of 4, oops, what happened here, is going to be 16. So 16 positive x 2 times, oh, I apologize. I'm looking closer now. Okay, that's a 3. It's really small on my screen, so you're probably like, Kyla, where'd that 2 come from? It's a 3. So my apologies. So it's going to be 3 times 4. So it's going to be x to the power of 12. So 16x 12. For the next one, we get -3 to the power of 3, and we have x4 to the power of 3. So negative 3 to the power of 3 is going to be negative 3 times negative 3 times negative 3. That's going to give you an overall negative, because there's an odd amount, 27x to the power of 12. So again, we're just multiplying those exponents. Sorry. If I'm pausing, it's because I'm coughing. So you're like, where'd she go? Okay. So in the next one, we actually have two things. So as we move forward, we have to remember BEDMAS. So if you don't remember BEDMAS, it's a time to learn it. But basically, BEDMAS tells me do your brackets first, your exponents, your division and multiplication have to happen in the order they appear. So that means that if multiplication comes first, then you can do multiplication first. But if division comes first, then you can do that too. And then addition and subtraction also is in the order in which they appear. So brackets means like if I have 2 plus 4 in a bracket and then I have it squared, we'll talk about this in future chapters, but it means that you have to do the work inside the brackets first. So we're not going to do 2 squared and 4 squared. We have to do the operation that it's telling us to do inside the brackets. So we'd get a 4 plus 2 gives me a 6 squared, and that gives me 36. So why am I telling you this? Because we have, I'm just going to write it bigger so that when I'm leaning back here, I can see what I'm doing. So we have x7 squared, 2x cubed. Okay. So I have two things happening here, but I'm going to deal, before I actually multiply the two brackets that are side by side together, I'm going to deal with these exponents. So my x has a 7 raised to an exponent of 2, so I multiply those exponents. So again, x to the power of 14. I'm going to keep my brackets here though, because I'm not actually done all the math. So I'm going to deal with these exponents in the second term first. So remember, the 2 is getting raised to the power of 3. So 2 cubed gives me an 8. And then x is 3 times 3, which is a 9, right? So I hope that makes sense. But this breaks down into 2 cubed times x cubed, which is where that 8 came from. Okay, but I'm not done because I can simplify this further, right? So there's a 1 in front of that first x. There's a 1 in front of that one, so 1x14. So when now I'm just going to go back to my previous rule about when I have a bracket times a bracket. So 1 times 8, just an 8. And because my letters are the same, so they're both x's, I can add those exponents together, right? So I can go 14 plus 9, right? I hope that makes sense. Okay, so we get 8x to the power of 9, 23. Is that right? I think so. Okay. So again, if that doesn't make sense to you, or you've forgotten that rule, you can just rewind this video. But that goes back to the rule we learned earlier in this video about when we have two letters beside each other that have the same exponent. So not our addition subtraction rules, just our multiplication rules, our original one we learned. And that would be your final answer. So that's like kind of what we consider like a two-step or a multi-step question, and how we would solve it. Okay, I'm going to pause just for a quick second here and grab some water. Okay, so onward. The distributive law. So this law is basically what we call expanding through the brackets usually. We don't, I mean, either or, it's a distributive law, but we can also say expanding through the brackets. So it means exactly what expanding through the brackets means. We have to bring whatever's on the outside of the brackets through. So this A has to be brought through the B plus the C. Now you're saying, Kyla, but you just told me in the last one that you have to do inside the brackets first. True. The only thing about the previous example I had, like I had a 2 plus 3 to the power of 2, we had two numbers that we were actually able to combine. But in these cases, So this example here, I have a 4a plus a 2b, and we know with our addition rules, right, our addition and subtraction rules, I can't combine those any further because they're different letters, right? So that goes back to the previous video with addition and subtraction. So I actually can't combine those any further. So for that reason, I have to use what's called the distributive law, or expanding through the brackets. So it means that this 3 has to be multiplied by the 4a, and the 3 has to also be multiplied by the 2b. So let's use some colors here. I'm going to erase that, and I hope that this all makes sense to everybody watching, but give it a go. Okay, so I hope that this all makes sense to everybody watching, but give it a go. Okay, so 3 times 4a. So I'm going to do this in blue. So that means I have a 3 times a 4a, right? Then we're going to switch to red. There's also 3 that has to be brought through to this term. So I have plus in between because it's a positive sign here, but we're going to use a plus every time. Sometimes the sign will change, but it depends on what the sign is of the terms. But anyways, plus 3 times 2b. So that second arrow is 3 times the second term. I'm just going to switch back to black here now. Actually, no, we'll keep it in blue. So 3 times 4a, this goes back to just our multiplication rule, so we can just multiply those coefficients. So 3 times 4 gives me 12, and then the a, and then red. And then we have 3 times 2 gives me 6, and I have a b left. So can I go any further? No, because I can, again, we go back to our addition and subtraction rules, and those tell me that I actually can't combine these because they're different variables. So if they were multiplied together, different story, but because they're being added, we cannot combine these. I hope that makes sense. Okay, so now we're going to combine a couple of the rules together. And this probably looks more similar to the assignment questions that you came to this video for, but I always start with the simpler ones first, especially for those who are new to these types of things. So let's let's look at the first one. So 2x squared cubed. So again, the 2 is getting cubed. So this 3 gets brought through to both. The 2 gets cubed and the x squared gets cubed. Okay, so the 2 cubed is going to give me an 8. And x squared to the power of 3, again, this is when I'd normally ask you, what do? We multiply the exponents, 2 times 3, so that gives me that 6. I'm going to keep this in brackets, and I'm going to write out the 3x minus 2. There's nothing I'm going to do yet. This is my first step. So this is one of those like multi-step questions. So I'm going to end up erasing this after because I think each one of these is going to take up a considerable amount of room. But so now I have this that has to get brought through to the first term and the second term. That didn't really go where I was supposed to. Let's try that again. Oh my goodness. Okay. Anywho. That's better. Okay. So we'll call this the first arrow and the second arrow because I'm not going to switch back and forth to colors because it's just too much. So the first arrow means that it's going to be that first number, or sorry, first the 8x6 times the 3x, right? So we're multiplying those two together. So you know what, for this one, actually, I'm going to write it out. So I have 8x6 times 3x plus, so again, I'm just always plopping that plus sign in between there so that I don't think I'm multiplying everything because these aren't all getting multiplied together, either being added or subtracted. So now I have an 8x6 times a negative 2. So make sure you take the sign attached to the number as well. So notice I didn't just write a 2, I wrote a negative 2. So the 8 times 3 is going to give me a 24. I'm going to add those exponents. So there's a 1 here. So this goes back to the other rule. 6 plus 1 gives me 7. Now, this is a negative 2, not a z. So I almost confused myself there. So I wrote a plus, but you know what? It's going to end up switching. And why? Well, because I have 8 times -2, so that's a -16. So you know what? Let's write it out for the sake of learning here. So we have a -16 and an x to the 6. The x can be combined with anything else. But these double signs here, when I have a plus and minus together, what do I know? Well, I know this is going to become an overall negative. So eventually you're just going to know in your head to just plop a negative in there. But for now, we have to go back to that rule about a positive beside a negative, or two opposite signs together results in a negative. So anyways, 24x7 minus 16x to the power of 6. So this is when I would ask you, can we go any further? Can we simplify this any further? And some students try to. They try to take those x's and subtract the exponents, but we cannot do that, right? So we're back to our addition and subtraction rules here, because these two terms are being subtracted. So my x has a power of 7 in the first one, and then my x has a power of 6 in the second one. So these actually can't be combined because my variables and my variables are the same, but my exponents are different. So the answer is no, you cannot go any further. I'll try to make my eraser gigantic here. That's better. Pretty sure there's a button where I can just erase everything. Yeah, I see it now. Okay, that'll be easier for the next time. Okay, so in this one we have 3x plus y plus 3x plus 5y. So we have to do these bit by bit. So this 3 has to be brought through, right? This is your distribution, or you're expanding through the brackets. And this 3 has to get brought through. So that's what I need to do first before I combine anything. So in my first arrow here, I have, right, so in this one I'm talking about, I have 3 times 3, so that gives me 9x. So in the second arrow, I have a 3 times a y. So I have plus 3y. So that, like, this all comes down to here. That's where that all came from. But now I'm going to deal with this disaster over here. So I have a 3 times an x, so 3x, and then I have a 3 times a 5y, so this is arrow 3, 4. So in arrow 3, I have a 3 times an x, which is 3x, and in arrow 4, I have 3 times 5y, which gives me positive 15y. So now the question is, can I combine any further? The answer is yes, because I have a 9x and a 3x, and then I have a 3y and a 5y. So the coefficients in front can be whatever the heck we want them to be, but the variables and the exponents have to be the same. And in this case, we have 2 x's and 2 y's, so we're good to go. So we have 9, 10, 11, 12x, and we have 15, 16, 17, 18y. So we have 12x plus 18y, and that is my final answer. Cool. Okay. Haha, I did it. Okay, that'll save us some time too. Okay, so let's move on to this guy here. So we have 2ab 4b squared minus 2a plus 3ab. So I don't know why I wrote brackets there. It's just going to be more. I don't know why I wrote brackets there. It's just going to be more confusing to you probably. Let's get rid of that. Oh boy, okay. 2ab. Okay, so in the distribution law, it doesn't just need a binomial in the second term, right? So a binomial meaning 2 terms, monomial is 1 term, trinomial is 3 terms. I think we covered that in the last video. I hope so. Pretty sure we did. So this gets brought through to all 3 terms. The 2ab gets brought through to the first term, the 2ab gets brought through to the second term, and the 2ab gets brought through to the third term. And the terms are separated by those minus and plus signs here, right? So that's what tells me I have 3 terms. So my first arrow is here. So it's going to be 2ab times 4b squared. So let's, you know what, let's write it all out. It's going to be really messy, but let's write it all out. So I have 2a, oh my goodness, off to a great start here. 2ab times a 4b squared. So that's my first arrow. My second arrow, right, is going to be a 2ab again, which I don't know why I keep forgetting to write the 2. It's been a long day. Okay, so we have a 2ab now times a negative 2a. That's that second term in there. Then I also have a 2ab, look, I did it right that time, times a 3ab. So this is my second arrow, and then this is my third arrow. So that's where those two come from. So I have 3 because I have a trinomial inside the So now this goes back to our multiplication rules. 2 times 4 gives me an 8. My a, and so we're just looking at this one. My a has nothing to combine with, so it's just an a. And my b also has nothing to combine with, so it stays as a b squared. That's a lie. My b does have something to combine with. There's a b1 there. So this should be a b cubed. So my a has nothing to combine with, my b does, because I have a b1 times a b2, and we know with multiplication I can actually add those exponents. So in the second one, I have a positive on the outside, but then I have a negative here, so it will flip to a negative because I have positive 2 times negative 2. So I get negative 4a. Now, again, there's little pesky ones all over here. So my a is now going to be squared because I have an a1 plus an a1, and then my b is just going to stay as a 1. You can write that 1 or you can't. It doesn't matter. Totally up to you. So that was from, this one's from arrow 1, this one's from arrow 2, this one's from arrow 3. So now in the last one, I have a 2 times a 3. That gives me a 6. I have an a, that does not look like a 6, sorry, an a squared because there's 1s all over these, and a b squared. So I'm just adding those exponents. So now the question is, can I go any further? Can I simplify this any further using my addition and subtraction rules? No, because I have an ab cubed, then I have an a squared b, then I have an a squared b squared. So none of these are like terms, right? When we talked about combining our like terms, none of these are like terms. So this would be my final answer. Okay, cool. I'm gonna erase that. All right, one more, and then we're gonna get into division. So I have negative 5 AB plus BC minus 4 AC minus AB. So I have 2 different things that need the distribution property. It's very similar to the second one we did, but this gets brought through the brackets and this gets brought through its brackets. So I'm not going to write each arrow out, and I'm not going to write each bracket out for sake of just probably your sanity, and hopefully by now it's clicked. But the first arrow in this one, this little guy, we have negative 5 times AB, so that just gives me negative 5 AB. In the second arrow, this guy, we have negative 5 BC. In the third arrow, I have negative 4 AC because I have a negative 4 times AC. And then in the fourth arrow, here's the tricky trick. We have a negative 4 times a negative AB. So we end up with a positive 4AB. I hope you know where that came from. This negative 4 times this negative AB becomes a positive 4, then an A, and then a B. So can I simplify any further? I have an AB, a BC, an AC, and an AB. Well, these two are at least the same. The other two are not. So negative 5 plus 4 gives me a negative AB, or negative 1 AB. You could put a 1 there. Minus 5 BC minus 4 AC. because those other two, unfortunately, cannot be simplified any further. So that would just be your final answer. And again, you could have had a 1 here. Oops, you know what I mean. Okay, on to division. That is not overview. You know what, we're going to skip that because we did lots of examples. But again, if you have any questions, let me just double check this one. You know what, let's not skip this. We're going to skip the first 3, but those last 2, I think would be good to do. So in this, we're going to do this one first. I have 2x squared to the power of 3. So the 2 gets cubed, that becomes an 8. The x becomes a 6, right? Because I multiply my exponents, I don't add. And then my negative 4x squared, my negative 4 gets squared, it becomes a 16. And then my x becomes a 2. And I feel like I may have lost most of you on that one. So let's backtrack here. So my x becomes a 2. And I feel like I may have lost most of you on that one. So let's backtrack here. So my 2 is cubed, my x squared is cubed. This is all its own thing. And then in the second one, my negative 4 is squared and my x is squared, right? Because that exponent gets brought through to every single thing inside the brackets, the coefficient and the literal coefficient and the variables. So that is where the 2 cubed becomes an 8. This one, I know I multiply my exponents, so negative 4 squared becomes a 16. You can put that in your calculator. And then x just becomes an x squared, so that's where it came from. But I can go a step further, right? So I can do 8 times 16, which gives me 128. And then now I'm not multiplying my exponents, I'm switching to a different rule of addition, or sorry, not addition, but adding my exponents because it's the multiplication rule. So 6 plus 2 gives me 8. So that would be my answer, 128x to the power of 8. And then the last one. So maybe in the last one you were asking, I'm always trying to think about the questions that students might ask, so that because you're not here to ask the questions. But in that last one I did, you might have asked, like, why didn't we multiply these two together first? Well, that goes back to my BEDMAS, right? So I do my brackets exponents first before I do division multiplication, and then I do addition subtraction last. So that is important in this one because this one has that extra little 2 out front, or out back, I should say. So we have a negative p squared q squared. I hope there wasn't a squared there because I wrote all over it. No, okay, that's right. And then we have 4pq4 and then a negative 5. So this 2 gets brought through to this, and to this. I don't know if we did a triple whammy like this yet, but the 2 gets brought through to all the letters and all the variables. So the negative 2 gets squared, that becomes a 4. The p squared gets squared, so that becomes a power of 4. And the q also gets squared, so that becomes a squared. Right? So that 2 gets brought through to every letter and the coefficient. I'm going to put those in brackets, and then I'm just going to write out everything else because I'm not actually able to simplify anything much further yet. Because none of the other ones have an exponent outside that bracket. So now I can just multiply my 4 times 4 times negative 5. So I think that's 80. Let me just check. 4 times 4 times 5. Yeah. So negative 80. P, I have 4. I have 5 P's. Q's, I have 2. I have 6 Q's. And that is my final answer. There's nothing else I can do there. I'm really hoping at this point I haven't made a bunch of errors that you're like, Kyla. And hey, I do make mistakes. It's okay to make mistakes. Okay, one sec. Okay, so now we're going to quickly do some division. we really don't have that much. We only have 6 more slides. The bulk of it is multiplication. Division ends up being tending to go a little bit quicker. So when we're talking about dividing, we're trying to find factors or things that are the same in the top and the bottom, so the numerator and the denominator. So in the first one, and we want to factor those out. In other words, cancel those out or divide them out. So I have a 3xy over an ax. So the top has a 3, an x, and a y, and the bottom has an a and an x. So the thing that's common in both are these x's. So I can cancel those out or divide them out because anything divided by itself is 1, right? So if I had x squared over x squared, that would become a 1. If I had x6 over x6, that would become a 1. And you could write the 1, so you'd have 3 times 1 times y, but there's really no point because the 1 isn't going to change anything, right? So we just kind of cross it out and make it disappear. Does it become a 0? No. It becomes a 1, but 1 times anything is itself. If it was a 0, everything would become a 0, so it does not become a 0. In the second one, same thing. I have an x common in both, so the x and the x cancel. I'm not left with a 0 on top, I'm left with a 1, right? Because 0 over something is not the same as 1 over it, right? Because that'll become a 0. So, sorry, didn't get to turn the mic off there. Yeah, so we're going to cancel. So we're going to sort of solidify this rule a little bit further along here. So now, specifically, we're just looking at dividing a monomial, so the single term, by a monomial involving powers. So this just means a variable, like the same variable, same letter divided by the same thing. So I'm going to just write this out. I have a times a. The little dots mean multiplication, by the way. We also use these, which could become confusing. Probably should use brackets, but just means multiplication. We have all sorts of shorthand in math. But yeah, so I have 5 a's on the top and 3 a's on the bottom. So this can cancel this one can cancel this one, and this one can cancel this one. So all I'm left with is 2 a's on the top, or a squared. And then on the bottom, I'm left with a 1, but we don't have to write that, right? So I'm left with a squared. But the other rule, or the other way to do this, is using what we call subtraction, the subtraction method. So 5 take away 3. So when we have division, like in addition, in multiplication, we were able to add those exponents, right? So in division, we're actually able to subtract. So it's the opposite, which makes sense. Sorry. 5 take away 3 is going to be a squared. So we have an a to the power of 2, which we also got in the first answer. So we can also use those exponents and then subtract them, and it makes our life way easier. So some rules. To divide powers of the same base, subtract the exponents and leave the base the same. So that's basically what we just did. We leave that variable or that base the same, and we just subtract those exponents. The 0 rule is any base to the power of 0 becomes a 1. So I mean, we could have went over this in the multiplication booklet, but if I have 2 to the power of 0, it's a 1. If I have, well, that kind of looks like a z anyways, b to the power of 0 is 1, and so on. So anything to the power of 0 is 1. And then there's this negative exponent rule. The reason this is brought up, I mean, it's really useful in all math, but as you go, if you are working in the booklet, you'll notice some of the booklets, and I'm going to do a little example at the bottom here, have it, there's 2 formats. So if I have a to the power of -3, right, which is possible, we can have negative exponents. I can also write this as 1 over a cubed. It's the same thing. And you're probably asking why and how. And just as like sort of a quick, I don't know, why, I guess. You know what, let's just erase all of it. Sorry. Okay, so we have, let's say I had a to the 5 over a to the 9. So I have 5 a's on the bottom. Why did I pick 9? I don't know. And I have 9 on the bottom. 3, 4, 5, 6, 7, 8, 9. And I have 9 on the bottom. 3, 4, 5, 6, 7, 8, 9. I was committed to it. Okay, so I can cross out 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. I'm left with these 4 A's, right? So I'm left with just a 1 on the top and an A4 on the bottom. So this is great. That's one way to write it. But if I use my subtraction method and I went 5, take away 9, right? I'd get a to the negative 4. 9, a to the negative 4. And these are the same. A to the negative 4 is also 1 over a to the 4. And we saw with the two different methods we used, we got different types of answers, but they're the same. So if ever you see on an answer key 1 over or the numbers on the denominator on the bottom, if we wanted to bring that up, we could bring it up and make it a negative exponent. So another example of that. If I had x squared over y4, I could also write this. It's terrible. These are equivalent. I could also write it as x squared y to the negative 4. Those are the same. So if I don't want to have a fraction, I can bring that y up, but if I'm going to do that, I have to flip that exponent. So that's a quick explanation of that rule. Okay, so in this example, and the book gives plenty more of examples. I prefer the subtraction method, and most of my students honestly do. It seems to be a little bit more streamlined, but in this first solution, we have 6a to the power of 4, b to the power of 6 over 2a squared b squared. So what we're going to do is we're going to, and we haven't done a very complicated example yet. We're getting a little more advanced here. So we just take the coefficients, so the numbers in front, we're going to take those out and we're going to split it up. So notice how we split it up. 6 over 2, that becomes a 3. So 6 divided by 2 is 3. Then my a to 4 over a squared becomes a to the power of 2. And then b6 over b2 becomes b4. So what I could have done, and I mean it is the exact same thing. 6 over 2 becomes a 3, that's for sure. But I'm going to go 4 minus 2 and b6 minus 2. So I get a2 b4. So I did get to the answer the same way, but instead of sort of figuring out which ones cancel, we can just do the subtraction method. So our coefficients we deal with independently. If you need to punch this into a calculator, that's totally fine. Sometimes it doesn't become a whole number, it stays as a fraction, and that's okay. We'll look at some of those too. Don't be scared of fractions. Lots of people are though. Okay. So, oopsie doopsie. Oh my gosh, okay. So, my 8 over 10, I'm just going to write it out and just leave it. We'll figure out if we can reduce it later. I have 4 take away 4. I have Q7 take away 9. And I have R13 take away 9. So 8 over 10, it doesn't become a whole number, but it can be reduced. So we can actually get that into a lowest term fraction. And a really simple way to do that, we're going to pop over to the scientific calculator. We haven't seen it in a while. And I will show you a very quick way to, I mean, that's a pretty simple one to simplify. We would just divide them both by a common factor, but some of them aren't so simple all the time. So if I want to get into the lowest terms, I'm going to go 8. So if I want to get into the lowest terms, I'm going to go 8, use my fraction button over 10, and equals, and it's going to reduce my fraction into lowest terms for me. So we divided both by 2, right? So 8 divided by 2 is 4, and 10 divided by 2 is 5. But again, at this level, this isn't the type of stuff I'm like expecting to see from you. You can use a calculator and just get your lowest terms fast if you need to, because sometimes the numbers will be a little bit more like trickier to use. So anyways, back to, oops, that's not what I wanted to do. You might see me for a second. Oh, okay. Okay. So we get 4 over 5, p to the power of 0, q to the power of negative 2, and r to the power of 9, 10, 11, 12, 13, 4. So that p to the 0 becomes a 1. I'm just going to cross it out. You could write it as a 1, but again, why write a 1? Like it's not really going to change anything. It just adds more numbers to the mix that we don't need. So we get our final answer, 4 over 5, q to the negative 2, r to the power of 4. This could have been written as 4r4 over 5q squared, right? The q squared could come down to the bottom. The 5 is already on the bottom. It's part of the denominator. So it can be rewritten as this way. Both are acceptable answers. Students typically like the negative one. It just seems to make more sense. I don't expect you to be able to flip back and forth, by the way. It's just to show you that there are different ways to show the answer. Okay. So the next one, we have 4 divided by negative a half. So again, you're going to pop over to your scientific calculator. I'm not going to pop it up again because just sake of time. We're going to go 4 divided by, you're going to use that plus minus key, 1, ABC key, 2, right? So you're going to divide by your fraction. So 4 divided by negative 1/2, it'll give you negative 8. If that's not something you remember how to do, you can go back to the calculator booklet or ask your teacher, but 4 divided by negative a half is going to give you a negative 8. So that's going to give me negative 8. And then x, I have 4 take away 2. And then for my y's, I have 7 take away 4. And then my z's, I have 10. So I have negative 8x squared, y 3, z 10 as my final answer. Okay. I don't know if I have one in the next slide, but while we're here and while I'm thinking of it, sometimes, like let's make one up, sometimes, and I'll show you what I mean. Like if we had, so sort of like the third question, so let's just make it easier though. If I had 4 over negative 2 x, we'll still do it squared, but then I had my z10 on the bottom, and my, we'll just do a y7 on top. So 4 divided by negative 2 gives me a negative 2. My x, 4 take away 2 gives me a 2. My y, 7 stays as a 7. Now the question is, so in this one our z10 was on the top and that was great because we just kept it there. But in this one my z10's on the bottom. If I want to bring it up to the top, because there's no other z's to combine it with, but if I want to pop that up to the top, I can't just do that. I have to make it into a negative exponent, right? So on your answers, if you're going to bring that up, you have to flip that into a negative exponent. Or you could have kept it as negative 2 x squared y 7, and you could have just kept that z10 on the bottom. Totally fine with that answer as well. Just if it's on the bottom and you want to bring it up, it has to become a negative because that's that rule. So usually there's like one of those on the assignment, so I wanted to cover that because I actually don't know if I have one like that. Okay, now we have division, so the last 2 slides, division of a polynomial by a monomial. So if I have a polynomial being divided by a monomial, so the top is 4 different terms being divided by 1 term on the top, what I do, or can do, I just realized I can make my pen smaller. Oh my gosh, game changer. I can separate these into a bunch of different fractions. So I'm going to like group all these. It looks like a disaster, but you'll bear with me here. Let's maybe go a little bit thicker than that because it's pretty small. Okay. Managed to cut that off halfway at least. So in the first one, I'm just going to write it out as separate fractions. So I have 12x4 over negative 2x squared plus 16x cubed over negative 2x squared minus 8x squared. Oh my gosh, I can't read it now. Yeah, okay, that's right. 8x squared over negative 2x squared plus 4x. Sorry, I had to just adjust my headset there. Over, 4x over negative 2x squared. So basically it just means I'm going to separate them all into their own little thingy-majiggies and then simplify. So 12 divided by negative 2 is going to give me a negative 6. Again, use your calculator if you need to. Then I have a 4 take away 2. Then my 16 divided by negative 2 will become a negative 8. So I went ahead and wrote that plus sign, but I'm going to go erase it because I don't really want to have to do more work than I do. That'll become a negative 8. And then I have x3 take away 2. And then my negative 8 divided by negative 2 becomes a positive 4. x2 take away 2. And then I get minus 2, because 4 divided by negative 2 is negative 2. x1 take away 2. Okay, so all I did was take all my numbers, like my coefficients, and simplify them using a calculator or whatever. And then I subtracted my exponents with my variables that were the same. So negative 6x squared minus 8x to the power of 1. You can put the 1 there, you don't have to, doesn't matter. And then 2 take away 2 is going to give me a 0. And then negative 2 to x to the power of negative 1. So this 0 will become a 1. So we're going to simplify this as much as we can. So I get negative 6x squared minus 8x plus 4 minus 2x to the negative 1. And then the question is, and sometimes you can I simplify plus 4 minus 2x to the negative 1? And then the question is, and sometimes you can I simplify it any further? But I can't, right? Like each of these, we're back to our addition subtraction rules. Each of these variables has a different exponent, and then this one's just a constant. So I can't actually simplify that any further. So that would be my final answer. Okay, let's try the next one. Okay, so the next one, same thing. We're going to split it into 4 fractions. So I have 6p squared q cubed over, I'm going to stop saying everything out loud because that's probably super annoying. And while I'm writing all that out, again, you do not need to write this step at all. The more work you show, the more marks part marks you get it, like if you get the question wrong. But it's whatever your brain wants to do. You also don't have to show every step I show. Like if you went to school with a teacher that told you had to do it this way or it was marked wrong, even though the solution was wrong or right rather, like in this program, it's not like that at all. So whatever method you do in your head or on paper is fine as long as it makes sense to you. And sometimes maybe I'll even get you to explain it to me because I also think it's really cool that some people think differently and do things differently. I find it quite fascinating. Anywho, 6 divided by negative 3 gives me a negative 2. P, I'm not going to write all my exponents out this time. You know what? No, I will. Will I? Just going to be really, no, it's fine. Okay, 2 minus 1, q, 3 minus 1. Negative 9 divided by negative 3 will becomes a positive 3. And then I get p2 take away 1, q1 take away 1, so that'll become a 0. Oops, got ahead of myself. Plus negative 3 divided by negative 3 is 1. P1 take away 1, Q2 take away 1, and then minus, like minus 1. I'm not going to write the 1, but yeah, I'll write the 1, whatever. P1 take away 1 and Q1 take away 1. Sorry. Oops. Okay, so I get negative 2, and then I get P to the power of 1. We'll just leave it like that. Q squared. Oh, I hope it's still recording. Something weird just happened. Okay, good. Whew. Oops, whatever. Okay, so negative 2p1q squared plus 3p, 2 take away 1 is 1. Q to the 0, but you know what? I'm just going to cancel it out. I'm going to cancel this one out too, and I'm going to cancel these two out. You could have also done it up here if you wanted, like you can go away, and you can go away. You know, you could have done that too, but anyways, I'm just doing the subtraction method just to keep things a little bit, I don't know, similar. Okay, plus q, because 2 take away 1 will become a 1. I'm not going to write the 1. You could, though. And then minus 1. So the biggest sort of mistake students make in this last term is to just think it becomes a 0, but there's still that negative 1 out front. And because this becomes a 1 and a 1, it's all multiplied together. So I do have that negative 1 at the very end. So you are probably, or have at some point in this video, or maybe you haven't, and that's fantastic, but you may have yelled, "What is going on? There are so many rules. This is awful. This is horrible." And most people are right there with you. But I will say, the more practice you do, the more questions you ask, the more just the more practice you do, you'll get better at it, right? Like if this is a brand new concept for you, that's fine. Like give yourself some grace. Allow yourself yourself some time to learn the concepts. And the great thing about this is you can pause me, you can fast forward, you can rewind. And then also you can meet with me or your teachers and ask more questions if it doesn't make sense to you for clarification. So please don't give up. Algebra is hard. It is really hard. So don't think that you're not, able to do this. It's just hard right now, but it doesn't make it impossible. I've seen students who, came into the program and weren't able to add whole numbers together, and they got through all of this. So it's just a matter of taking time and practice. So I just don't want you to give up. But maybe you've kept up with me this entire time, and that's amazing. I hope so. Okay, last one. The reason I threw this one into there is because it's the super annoying fraction in the bottom. So I wanted to do one with a fraction. I'm not going to write out each one this time just because it's just really a pain in the butt. But in your calculator, you're going to, you know what? And so since I'm not writing it all out, let's bust out the calculator one last time. This is the last slide anyways, bear with me. This has taken a little bit longer to go through than I thought, but that's okay. You could have paused and had dinner by now if you wanted to. Okay, so for the first one we had 32. Okay, so for the first one we had 32 divided by, I think it was a negative. Let's pretend like it was. It might not have been though. But anyway, if it was a negative, we're going to hit that one. And then 1 over, right, that's our fraction button, 2 equals, that's going to give me negative 64. So lots of students probably would have just divided by 2 and got like 16. But when we divide by a half, it's actually the same as multiplying by 2. But you don't need to know that. You can just use your handy dandy calculator and divide by the fraction. Oh, I thought maybe that would have been my trick, but it's not. Go all the way through this whole thing. Okay. All right. It wasn't a negative. That's hilarious. So it's fine. It's 64 still, but it's not a negative. 64. It's blue now, so cool. And then we have, let's deal with our x's. So I have x3 minus 2, so that's an x. I have y2 take away 2, so that'd become a y0. Let's just write it anyway. And then I have z1 take away 1, so that actually also becomes a 0. Then I have negative 4 divided by 1/2, so that'll become a negative 8, so that one at least stays as a negative. And then I have 1 take away 2, so that becomes a negative 1. Maybe I should have written it out, but hopefully you're keeping up with me so far. So I have a 1 take away 2, so that's a negative 2. And then my y2 take away 2 becomes a 0. My z1 take away 1 becomes a 0. And then negative 18. Sorry, I thought I had a sneeze, but I didn't. Okay, negative 18 divided by 1/2 becomes negative. 18 divided by a half, yes, okay. Same as multiplying by 2, so that becomes negative 36. X, 1, so my X has 1 take away 2, so negative 1. My Y is 2 take away 2, so it's a 0, and then my Z is 2 take away 1, so just a 1. Yeah. Okay. Gone, 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 gone. So I'm left with 64x minus 8x to the negative 1. You're gone too. Minus 36x negative 1z. And that is my final answer because I cannot combine these. I have an x, then I have an x with a negative 1, and then I have an x with a negative 1 with a z. So that is your final answer. And that's it for today's lesson. Again, just if you have any questions, please ask. If you hate all of this, most people are right there with you, but please ask questions. Don't give up. It is hard stuff. We also got through a lot in one lecture, so if you need to go back and rewatch stuff, that's totally fine. But yeah, thanks for watching.